Imagine a world ruled by creatures stranger than fiction. Giant insects hum through the air, while massive reptiles stalk the land and swim the seas. This was Earth millions of years ago, but this world teeming with life could be snuffed out in a geological blink. These are the mass extinctions, events so devastating that they redefine life on Earth. 5 times in our planet's history, the intricate web of life has been nearly torn apart. These cataclysmic events serve as stark reminders of the power of nature and the fragility of existence. These events weren't just periods of heightened background extinction. They were rapid, widespread die-offs that reshaped the evolutionary trajectory of life. Entire ecosystems collapsed. Dominant species, like the dinosaurs, vanished. These weren't simply tragedies, they were resets, clearing the stage for new forms of life to emerge and flourish. The history of life on Earth is punctuated by these dramatic upheavals. Each extinction event tells a story of loss, but also of resilience. Understanding these events is not just an academic exercise, it's about understanding our planet's past and perhaps glimpsing our own future. The history of life on Earth is not a straight line of progress. It's a story written in fits and starts, punctuated by periods of incredible diversity and devastating loss. Mass extinctions are the most dramatic chapters in this story. They are moments when the normal rules of survival are suspended and the fate of entire species is decided by forces beyond their control. These events leave behind more than just a trail of fossils. They leave scars on the planet itself, altering the chemical composition of the atmosphere and the oceans. The very rocks beneath our feet bear witness to these ancient disasters. Studying these scars allows scientists to piece together what happened during these cataclysmic events. By analyzing fossils, sediment layers, and geochemical signatures, they can determine the timing, duration, and potential triggers of these extinctions. Understanding the causes and consequences of past extinction events is crucial for understanding the present and future of life on Earth. The more we learn about these events, the better equipped we are to protect the planet's biodiversity from future threats. Scientists have identified 5 major extinction events in Earth's history, each with its own unique set of causes and consequences. These Big 5 extinctions stand out for their sheer scale and impact on the planet's biosphere. The first mass extinction, the Ordovician-Silurian extinction, occurred around 443 million years ago. It wiped out an estimated 85% of marine species, likely due to a combination of climate change and volcanic activity. The late Devonian extinction, around 375 million years ago, is thought to have been caused by a prolonged period of environmental change, including ocean anoxia and global cooling. The Permian-Triassic extinction, also known as the Great Dying, occurred around 252 million years ago and was the most severe extinction event in Earth's history. It wiped out an estimated 96% of marine species and 70% of terrestrial vertebrate species, likely due to massive volcanic eruptions that triggered catastrophic climate change. The Triassic-Jurassic extinction, around 201 million years ago, is thought to have been caused by massive volcanic eruptions or an asteroid impact, leading to the demise of many large reptiles and paving the way for the rise of the dinosaurs. Finally, the Cretaceous-Paleogene extinction, around 66 million years ago, wiped out the dinosaurs and many other species, likely due to an asteroid impact. Each of these events dramatically altered the course of evolution, wiping out entire lineages and creating opportunities for new forms of life to emerge. Understanding these past events is crucial for understanding the resilience of life on Earth and the potential threats to its future. Section 4. Agents of Chaos. Mass extinctions are triggered by a perfect storm of events, a confluence of catastrophic factors that disrupt Earth's delicate balance. While the specific causes of each extinction event are still debated, scientists have identified several key players in these planetary dramas. Asteroid impacts, like the one that ended the reign of the dinosaurs, are capable of causing widespread devastation. The impact itself unleashes unimaginable energy, triggering earthquakes, tsunamis, and wildfires. But the real damage comes from the aftermath. The impact throws millions of tons of dust and debris into the atmosphere, blocking out the sun and plunging the planet into a prolonged period of darkness and cold. Volcanic activity is another major driver of mass extinctions. Massive volcanic eruptions, especially those that span millions of years, can release enormous amounts of greenhouse gases and toxic chemicals into the atmosphere, leading to rapid climate change, ocean acidification, and widespread ecological collapse. Climate change, whether caused by volcanic eruptions, asteroid impacts, or other factors, is a recurring theme in mass extinctions. Rapid changes in temperature, sea level, and ocean chemistry can disrupt ecosystems and push species beyond their limits of tolerance. Other factors, such as changes in ocean currents, sea level fluctuations, and even the evolution of new, more competitive species, can also contribute to mass extinctions. These events are often complex and multifaceted, involving a combination of factors that interact in unexpected and catastrophic ways. By studying the geological record and modeling past events, scientists are working to understand the complex interplay of factors that can lead to mass extinctions. This knowledge is crucial for assessing the risks to our planet's biodiversity in the face of current and future environmental change. Section 5. The Great Dying. The Permian-Triassic extinction, also known as the Great Dying, stands as the most severe extinction event in Earth's history. Occurring roughly 252 million years ago, it wiped out an estimated 96% of marine species and 70% of terrestrial vertebrate species. The oceans became almost uninhabitable and the land was left desolate. The culprit behind this mass extinction was a series of massive volcanic eruptions in what is now Siberia. These eruptions, which lasted for hundreds of thousands of years, released enormous amounts of greenhouse gases, such as carbon dioxide and methane, into the atmosphere. This led to a runaway greenhouse effect, causing global temperatures to soar, oceans to acidify, and oxygen levels in the seas to plummet. The environmental consequences were catastrophic. The oceans became warmer, more acidic, and depleted of oxygen, creating a toxic soup that suffocated marine life. On land, the intense heat and widespread wildfires decimated forests and other ecosystems, leaving behind a barren landscape. The Permian-Triassic extinction is a stark reminder of the devastating power of volcanic activity and the interconnectedness of Earth's systems. It highlights the vulnerability of life to rapid environmental change and the long-lasting impacts that such events can have on the planet's biosphere. Section 6. Death from above. The Cretaceous-Paleogene extinction, which occurred around 66 million years ago, is perhaps the most well-known mass extinction event, as it marked the end of the dinosaurs' reign. This event, however, was not a gradual decline, but a sudden and catastrophic event caused by a massive asteroid impact. The Chicxulub impactor, estimated to be about 6 miles wide, slammed into Earth near the Yucatan Peninsula in Mexico. The impact unleashed an unimaginable amount of energy, equivalent to billions of atomic bombs detonating simultaneously. The immediate effects were catastrophic, including earthquakes, tsunamis, and wildfires that raged across the globe. The long-term effects were even more devastating. The impact ejected billions of tons of dust and debris into the atmosphere, blocking out the sun and plunging the planet into a prolonged period of darkness and cold known as an impact winter. This sudden and drastic climate change caused a global collapse of ecosystems, leading to the extinction of an estimated 76% of plant and animal species, including the dinosaurs. The Cretaceous-Paleogene extinction is a stark reminder of the destructive power of asteroid impacts and the vulnerability of life on Earth to extraterrestrial threats. It also highlights the interconnectedness of Earth's systems, where a single event can trigger a cascade of consequences that reshape the planet's biosphere.